Hi everyone and welcome again to this Python course. Okay, so we've seen strings and we spent a lot of time working with text in the last section. We've also had the opportunity to do a lot of exercises regarding that, and I hope that you are now familiar with that type of object. Now, before we move to more complex objects such as lists or dictionaries, let's just spend here a couple of lectures on floats and integers and speak a bit about some functions that we can call on these types of objects. Okay, so this should be a brief section. We are not going to spend too much time on it, but it will be important for you to understand these methods that we are going to work with, particularly because this is the first time where we'll spend a lot of time speaking about uh, libraries and what they mean here in Python. So here we are going to work on these four Python floats and integers, and we are going to work on this notebook functions to call on floats and integers. Let's go, as usual, to our working notebook. I'll delete everything, and then here I'll open built-in functions. So built-in functions are functions that come with our base. Okay, now I'm going to spend here a bit of time discussing this concept of built-in functions, functions of libraries, and then external packages, which is something that's we are not going to deal with, and that will open us a new world here in Python. For now, it's important that you understand that built-in functions are functions that are readily available when you start your Python kernel or when you run your Python script off the bat. You'll understand the difference between built-in and library functions in a minute when we'll import the math library. And in this section, we are going to spend some time learning functions that we can apply on numbers, in this case, float and integers. Recall that one of the functions that we've learned that we can apply on these types of objects is, of course, the ABS for absolute value, where we can call ABS minus 10 and also ABS minus 10.2 that will return 10.2. We have other functions that we can do here in terms of mathematical stuff. For example, powers. We have the function called pow, P-O-W. And if we pass a number inside, the first number should be the number we want to raise to some power, and the second argument is the power that we want to raise to. So if I want 4 squared, or raised to the power of 2, I'll put a 2 after the comma. This is, of course, a multi-argument function. Okay, so it has the first argument, the 4, which is the number, and then it has the power that I want to raise my function to. If I run this, I'll have 16, exactly 4 raised to the power of 2. If I, for example, want a cubic power or a cubic calculation where I raise 4 to the power of 3, I'll have to change the second argument. If I want to check the arguments of power, I can go here, help pow, and I have x and y, equivalent to x, 2 asterisks y. And when we see that this is equivalent, it also takes a z, but don't worry about it, no need to go too deep into this function. Just know that this pow for 3 is exactly the same as doing for 2 asterisks 3. This will yield exactly the same result. I would say that nowadays most people use this syntax when they want to raise a number to a specific power. It's more common to use this way. Of course, we can apply powers to numbers. For example, pow 2.2 squared. It will yield this number. The same works with the 2 asterisk syntax. Okay, this works all the same. We can do these calculations in Python. Two more arguments that I want to show you, which are the max that take a certain list of numbers, for example, not a list, the object, but at least several arguments, and will give us return as the maximum value of these numbers that we give in the arguments. And this is a function that takes an infinite amount of arguments, for example, 10, 30, 20, 10. See what's the max? It's exactly what? The 30, right? And I can extend this to more numbers. If I put here, for example, 100, of course the max will change. Analogously, we have the min that will give us the minimum value or the lowest value from the elements that we have inside this function. Okay, so I hope that these functions made sense. Now, a really important concept here. I'm using this lecture also to explain more concepts outside of the realm of functions that we need to call in floats because they are relevant for other functions. We have certain functions, and most functions that we will develop will take keyword arguments. which means that we can name the arguments, and it's also much better for people to understand what we are giving to the argument if we have those keyword arguments. Let me exemplify here with the POW. The POW it's a good example because we have here an X and a Y, right? So if I go here and call POW, and the keyword argument syntax is the following. I have the name of the argument equals to something, so x equals to 2, which is x is the base of the power, and then y is equal to 2 as well, and y is the exponent of the power. If I try to run this, I'll have a mistake. It doesn't support the keyword argument syntax. Okay, there are certain built-in functions that don't support. Most functions from packages, which mean libraries that you'll get from the internet, and even some functions here will support that and will support this keyword assignment. There's an advantage on using the keyword assignment or the keyword argument type of syntax. First, we don't need to know the order of the arguments implicitly. We can basically switch these arguments with the keyword syntax, and they will be assigned specifically to the arguments that we want. And then it's easier for users to read. So let me pick up an example of another built-in function that will do that. So we have the round function, which will basically round a number, a decimal number, to specific decimal places. For example, if I have 1.102 or 1.102 and give comma 2, around these to two decimal places, which in the end is 1.1. Let me switch this just to make a bit more clear that it's two decimal places. So we have 1.13, which is the round that we are applying for two decimal places. This is rounded. If I, of course, put this on 6, this will be rounded to 1.14. Okay, so this is the round function. It works by using the number and then the number of decimal places that we want to round to. But this function supports keyword assignment. If I ask for the help on this function, I'll see that I have here number and digits. So I can go here to this round and do the following. I can use the syntax that we've learned regarding keyword assignment, which is number is equal to this, and n digits is equal to this. Basically, number, it's the number that I want to apply, round the number to given precision, and then digits, it's the number of decimal places. If I run this, I get exactly the same result because this function supports keyword arguments. Most functions that you will work with more advanced, particularly from packages and libraries or external libraries, will do support. It's a good way to point to the user what we are trying to do. Another advantage, although it doesn't have many practical use, is that we can switch the arguments of order and they will be mapped using their name, not their order. Okay, so in this way, when we use this syntax right here, when calling functions, we are implicitly giving the order of the arguments. Here with the keyword argument, we can switch the order of how we are feeding the arguments to the function. So let me do here more tests on the round function. For example, I can do for 3 dot something really big and put this to 3 decimal places, and this will round my number. And of course, I can also do the keyword assignment number and then digits equals to. We can do also the following. We can use the equal like this, okay? Or we can give a space here. There's actually a best practice between one of the two that I don't remember right now. I think it's without the space in this case. There are certain places where the space is a best practice. Not recalling right now, but I think it's without the space. Just know that this will work all the same. If I have a blank space between my equals, or I don't. Okay, this will work exactly the same. No syntax error at all when calling these functions. So these are some built-in functions that we probably will find throughout the course when dealing with numbers. Okay, numbers, by numbers I mean integers and floats. These functions that we've learned work for both data types. Now, one important thing that we need to get from this lecture is that there's a way to call arguments by the implicit order, which is mostly what we've been doing right now. And there's this way of doing keyword arguments or using keyword arguments where we point the argument to the name of the argument. Okay, during the rest of the course we'll intertwine between both. We shouldn't have many difficult functions that will require keyword arguments. Every time we are dealing with a lot of arguments, it's probably best to rely on keyword arguments calling so that it's easier to look into the code. That's it for built-in functions. Next, we are going to see how we can access functions that are not on base Python. This seems a bit of a mystery, but you will see how easy it is and how easy it is to pick up code from external libraries. I'll see you in the next lecture.